Well, good afternoon to you. I just woke up um, and I hope I'll be coherent through this talk. Um, the title of my talk is Monitoring Changes of Global Forest Biomass Carbon, Linking Science to Policy and to Market. What I'd like to do here today is just to show that the differences and maybe similarities that exist in our science problems when we look at the global forest carbon, and then how it links to policy and also to the market, and where are the differences in this. So if you look at this picture, which is from our recent paper in 2021, that we focused on quantifying the gross emissions, and these are the gross committed emissions from live biomass coming from fire, deforestation, and forest degradation. And these are all in the CO2 equivalent. And also the sink in the live biomass globally. And if you compare these numbers to what is coming out of the fossil fuel emissions, what is going to the ocean, what is the net sink that is coming to the land, you would see that the forest, the live biomass by itself, explains close to between 75 to 80% of the entire fluxes of carbon coming from the land part. So this is a very important component, and taking care of this in terms of quantifying it well, reducing its uncertainty is extremely important. Although within the science community, we're not only worried about this land part and quantifying it very well, we're also worried about on the live biomass, but we're also worried about all these budget imbalances that comes from different components where we have very not very good data sets. And that includes the dead wood, that includes the soil, that includes the lateral flow, and not including the other uncertainties that might exist in the fossil fuel. So this is a major goal of the science community, to be able to quantify this thing. And live biomass estimation globally and its changes basically feeds into improving these estimates. So both the science and the policy problem have few basically key elements in this. One is when you look at the overall picture of emissions to the atmosphere, although the land part remains a small portion of in the net compared to the fossil fuel, in the previous slide, we showed that in terms of the gross emission from land use change and also environmental change can be almost close to half of what comes out of from fossil fuel. So reducing that emission is extremely important. This component is also shows extremely uncertain because it comes out from a lot of data sets that is not necessarily quantified very well. Another problem that we deal with in the science community is to explain this interannual variability of atmospheric growth rate, which is basically almost agreed that it relates to the land component on the forest changes. This is another picture that comes from Grazi's paper that shows that currently what the bookkeeping models are giving you and the integrated assessment models are providing you has a major difference. This is where the top part is for current scenarios and in the future scenarios with what the national inventory data is giving you globally that comes in. And that big difference is huge. It's close to 5.5 gigatons of equivalent CO2. And this is another area that we need to really deal with, both in the science community and also in the policy community. So part of what the problem is that most of the national inventory data, first of all, in most of the tropical and non-Annex 1 countries, it doesn't exist, or it doesn't exist in a very coherent way. What exists in the Annex 1 countries are extremely discontinuous as well. Nationally, countries have their own patterns and ways of doing the inventory. the inventories have different cycles, and those cycles are not compatible with each other. And sometimes that causes problem. And this is an example of the US inventory, which is one of the best in the world. You have the number of plots in each of the states, the way the states providing the data sets in terms of the number of inventory over the past 25 years is extremely different. On the Western states, which has a lot of high biomass values, we have only one complete or close to two complete cycles of inventory in the past 25 years, whereas the Eastern areas is different. And the same thing goes in Europe, you know, the way the France and Spain or Portugal, they have their inventories, different time and different cycles and different densities. So there is an effort, there should be an effort to really make these NFI data spatially contiguous and temporally consistent. That might reduce the uncertainty that we have from the NFI coming in with the IMM. This is an example of it that we did in our recent paper for the US to make these annual maps of the forest carbon using NFI data at the resolutions of 100 meter for the whole US. So that means the biomass needs to kind of come in terms of mapping and making this thing contiguous in terms of spatially and also at the annual level to make it temporally consistent as well, because disturbance happens frequently in most areas in the US, especially Western states where the inventory is not good. The second problem on the carbon market, which is slightly different what we deal with in science and policy, although they're very much related. They're interested in investments on the carbon. First of all, they look at smaller scale for investments. They look at both the forest part and also the forestry part, meaning plantations and forest tree plantations. So that's extremely different from that science part. That means the scale of the activities here, the projects and land that they're investing on can go from a few hundred hectares to 10,000 hectares. And that's an important part of this thing. They're very much interested in high quality carbon credits. That means these carbons and the emissions and baseline and removals from these forests has to be really well quantified. As I said, scale is important. They're dealing with additionality, permanence, and leakage, which is this unholy trinity that is extremely important. That means it needs to have covering larger areas. It has to include monitoring over time to look at the impact of the climate. It also needs to be global in a sense that we can actually quantify areas that leakage is happening. Now, there are a lot of MRV systems being developed for these type of carbon market problems that it's mainly designed locally, but somehow that needs to come into a global system because we worry that these local MRV systems may not be able to really be very well integrated or consistent. So when we look at global problem, we would always find that all of these nature-based solutions or investments in the market may not really have an impact on the atmosphere. And that's extremely important. So here, removal is very important in terms of forests being established. Reducing deforestation degradation for net zero carbon and carbon credits is important. And also high forest areas, biomass areas with low deforestation is also important for So we come to the conclusion that the biomass must be mapped and must be mapped at the annual level, combined with the activity data, which is mapping deforestation, degradation, and reforestation to be able to really quantify the emissions. If we don't do that, we showed in our paper, and also I think another paper, Nancy Harris shows that there would be a lot of uncertainty and maybe underestimations on the emissions that comes globally. Part of it is because activity data doesn't happen randomly on the ground, and having emission factors, which is national or global, doesn't really help us to really quantify this thing very well. So there are two methods doing these things. There is one method which you have actually one carbon stock, and then you monitor activity data going globally. That's called gain and loss method. And Nancy Harris did this in her paper in 2021. Another approach, both of them recommended by IPCC, is a carbon stock take change approach, which you have carbon stock in year 1 and year 2, and you look at difference to see the net, but you can also integrate it with the activity data. It becomes close to the tier 3 type of approach between tier 2 and 3 to look at the emissions coming from this. In both cases, the need for biomass maps becomes extremely important. In one case, you have to create the maps more frequently. In one case, gain and loss, you can have once and move forward. I'm going to just...
1 minute, Sassan.
1 minute? Okay. So we did this thing globally in our paper in 2021, and we showed that to get it at 10 kilometers, we have an unbiased estimate globally. And that would allow us to actually create the changes of the forest biomass going forward, and we can reduce the resolution here or improve the resolutions, but there are always issues of separating the land use component from the environmental component. So recently we actually included ISAT and JEDI data. I'm just gonna move to one item to create a biomass globally, which is basically at 100-meter resolution, and the goal is to be able to do this thing over time going forward with the satellite data. I'm going to stop here to see if there are any questions, and maybe later on in the panel we can discuss in more detail. Thanks so much.